So let's remember binomial distributions. A binomial random variable represented the number of successes in a series of independent trials. And the sample proportion was found by dividing the number of successes by the number of trials. And so we get a proportion, which, as we knew from 7.4, if we have a proportion, then that distribution is approximately normal. If n times p is greater than 10 and n times 1 minus p is greater than 10. So the number of successes is for a binomial is also approximately normally distributed in that case. So recall that for binomials, the mean was found by n times p. The variance was n times p times 1 minus p. And the standard deviation was the square root of my variance. Now, of course, we can always still use the binomial feature to get the exact probability. But what if we want to approximate it with a normal distribution? That's what we're going to look at today. So to approximate with a normal distribution, two things have to be true first. So n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. If those two things are true, then the distribution is approximately normal with a mean of n times p and a standard deviation of the square root of n times p times 1 minus p. Now we do have to be careful with one thing. So a binomial distribution is discrete, whereas a normal distribution is continuous. So we'll have to make an adjustment from what we would use with a binomial. So let's look at the adjustment we're going to make. So suppose a fair coin is tossed 100 times. X represents the number of heads that result. And so we have a binomial distribution with 100 trials and a success probability of 0.5. If we wanted to compute the probability that X is between 45 and 55, 45 is less than X, which is less than 55, the probability changes whether we include those endpoints or not. Now, if we look at this distribution, notice where my whole numbers are: 40, 45, 50, 55. So the rectangles are going halfway between numbers. And if I am talking about the probability between 45 and 55 with just less than signs, then those rectangles should be excluded. So if I'm not including the rectangle that has 45, then I'm starting with this rectangle, which starts at 45.5. And if I'm not including the rectangle that has 55, then I have to end it a little bit beforehand. I'm only going up to 54.5. So we'll be computing the area under the normal distribution from 45.5 to 54.5. Now let's see the difference on if we're including those values. So if we're including those values, then the rectangles should also be included. So we're not just going to go to 45, we're going to go to the end of that rectangle, which is a half a step further, and the end of this rectangle, which is a half a step outside of those numbers. So we'll be going between 44.5 and 55.5. So we're going to have to ask ourselves, are we going below that number or above that number? And so we need to be careful about where our endpoints are. But let's see how we can find the probability of between 45 and 55. So X is the number of heads that appear when a fair coin is tossed 100 times. Our number of trials is 100, and our probability of success is 0.5. First off, does this meet our conditions? To check our conditions, we're going to check n times p and then n times 1 minus p. So that would be 100 times 0.5. Well, that's 50. And 1 minus 0.5 would still be 0.5. So 50. Both of those are bigger than 10, so we're good. Now, that means we're normally approximately normal. So what we're going to use is the mean for a binomial, which is n times p, and the standard deviation for a binomial. That's going to be n times p times 1 minus p. So that's going to be the square root of 100 times 0.5 times 0.5. And that gives me a 5. So if we were doing a binomial, we're finding the probability of being between 45 and 55. But since we're using a normal approximation, I have to go a little bit further to include the whole rectangle. So a little bit to the left of this one, and a little bit to the right of that side. Let me grab my handy dandy calculator. And we are going to go to the normal approximation. And we're going to put in a mean of 50 and a standard deviation of 5. And we want to be between two values. And those values are going to be, let's see, I have to flip back over here, 44.5 and 55.5. And we get a probability of 0.7287. Now let's look at if we're not between two numbers. If we are just less than or equal to 55. So here's 55 and less than is going to the left. But I'm going to have to start on this side so I include 55. So that means I'm starting a little bit to the right of 55. I'm adding 0.5. So I'm finding the probability that x is less than or equal to 55.5. Now, if I'm going to the right, greater than 55, we're talking about the area to the right. But to include that rectangle, I have to include the left side of that rectangle, which starts at 54.5. Now, to be equal to 55, remember, we don't have an equals option on normal distribution, but to equal 55, that's including just that one rectangle. And that rectangle starts at 54.5, it ends at 55.5. So we'd be including that whole rectangle. And so if you have issues with remembering these, we have some nice little graphs that help you remember when to add 0.5 and when to subtract 0.5. The Statistical Abstract of the United States reported that 66% of students who graduated from high school enrolled in college. 100 high school graduates are sampled. So N is 100 and P is 0.66. Let's check our conditions. So the first condition is N times P and then N times 1 minus P. So that'd be 100 times 0.66. I'm so happy it's a 100 for our sample size. That makes it super easy. And then the opposite of 66% is 34%. And our conditions check. Now let's talk about what we'll use in the calculator. We're going to use the mean of a binomial, N times P. And the standard deviation is the square root of N times P times 1 minus P. So the square root of 100 times 0.66 times 0.34. And I'm going to go over to my calculator. Square root of 100 times 0.66 times 0.34. Sorry, I'm doing it off camera. That's 4.737. Now, if we were doing a binomial, we're finding the probability that x is less than or equal to 75. But for the normal approximation, we're going to include the whole rectangle. So we're going to find the probability that x is less than or equal to 75.5. So 66, 4.737, and less than or equal to 75.5. And that gives me 0.9775. So that's how we're going to do a binomial approximation.